Hey, good morning, everybody, and welcome to our um, Essentials Math class. Um, I hope you had a good weekend. I hope you had some time to relax and refresh yourselves so that we can be ready and yeah, ready for the new week this week. So, welcome to all of you if you're watching right now on live stream, and welcome to you as well if you are watching later on. So, it doesn't really matter. Um, so, today we are going to be talking about the lesson three, which is expected value. Um, we've actually seen some expected value calculations in our previous lesson in lesson one and lesson two, but those ones are expected value in terms of how many are we expecting. But today it's going to be a little bit different because when we talk about expected value, we're talking about expected value of the money gained or money loss. So that's the only thing that's different when we talk about the expected value in this particular case. So let's go and read ahead. Any game or situation where you are gambling or investing an amount of money for a chance of winning some money, some more money, is what is called expected value. Okay, so when you buy a ticket like a raffle ticket, you go to a social, you go to a fundraising event, you put money in there, um, and you're hoping to win something bigger than what you actually put in to buy the tickets. So that's what your expected value is. The expected value of a situation is the average amount of money you can expect to either win each time you play the game or encounter the same situation. So, this is what you would expect each time we play the game. So, there's a formula right here, and EV stands for expected value equals P win. It means probability of winning. So, what is the chance of winning times how much money? So, see, there's a dollar sign. They're talking about how much, if you win, how much are you going to get? And then subtracting the cost to play. So, the cost to play could be the amount of money that you pay for to buy the ticket. Okay, so it says here this formula will help us figure out the expected value. Now, if we actually take a look at our formula sheet, okay, if you take a look at our formula sheet, um, this is the one that I gave you before. It says expected value as well, and it says here EV means expected value, probability of winning, chance of winning times money gain minus probability of losing times loss. There's This is another way of figuring out the expected value, but we find that this is actually a little bit more challenging. Okay, so this is, I mean, we're gonna get the same answer if we use this formula, but in our situation, we're gonna get the same answer if we just use this one. This is actually a simpler formula. So I'll just write this down. Simple simple formula for expected value. Okay, so I'm actually going to be teaching this formula for today. Okay, so it says here, please note two things related to this formula. This formula is not included in the exam formula sheet. And that's the one that I showed you a little bit earlier. If you want it for reference, it should be a self-made resource page. You can add parts of this formula if there are multiple winning conditions. Okay, so if there's different chances of winning, you will see an example during this lesson. Okay, so sometimes it's kind of hard to see what this is, where this is going. So an example would be the very best way to explain it. Okay, so let's read on and then see what we can figure out from here. So it says here a game is played where six-sided die is rolled. So we've seen in previous lessons what six-sided dice look like. So the cost to play the game is $5. So the cost to play the game is $5. If the number one is rolled, the the winner wins 25 bucks. Okay, that's a great thing because now it's describing how we win, what's the chances of winning. We will figure that out, and how much we're going to win. If anything other than one is rolled, the player loses the $5 bet. So that $5 bet is done. So this is what it would look like. What it would look like is that when we have the dice, okay, so I'm just gonna kind of draw a picture. You don't have to draw the picture of the dice. I'm just, sometimes it looks better when we have this. Okay, and I'll just go. So this is the dice. Now we have possible outcomes in here. The dice can have possible outcomes. And we've seen this before. Okay, so the possible outcomes are 1, 2, 3, 4, 5, and 6. So when we roll it, okay, I put away my dice. But if we roll our dice, these are the possible outcomes. What they're saying in here is that if one is rolled, so if one is rolled, then this is a win. And if any of these are rolled, so if two comes up or 3, 4, 5, or 6, then these are the if these comes up, these we're gonna lose. Okay, so what are we gonna do? It says on this formula we have to figure out what is the chance of winning, so the probability of winning. So we look at this one. If I win, what is the chance that I'm gonna win? There's the chance that I'm gonna win is if I get a 1. Okay, so how many ones are in here? How many ones are in there? There's only one 1. That's kind of funny sounding, but out of how many possibilities? How many possibilities here? There's out of 6. So there's only 1 out of 6 chances that I'm gonna get a 1. So, and if I win, how much money am I gonna win? I'm gonna win 25 bucks. So let's put it all together. Probability of winning. Probability of winning is equals, is equals to 1 over 6. And then expected value is equals to probability of win times number of dollars gain, or 1. Okay, so I'm basically just following this formula over here. Okay, so I look at that one. What is the chance that I'm gonna win? I'm gonna win if I see a 1 when I roll the die. So it's gonna be 1 out of 6, or 1 divided by 6, times how much money I'm gonna win, times how much money am I gonna win if I get a 1? I'm gonna win 25 bucks. So $25 minus cost to play. Well, how much does it cost for me to play this game? It says here the cost to play the game is $5. So minus 5. Okay, so now that we have our formula written down, we have substituted the values within the formula. Let's calculate it. So take out your calculator and let's do it together. So 1 divided by 6 times 25, and then minus 5. Okay, so okay, I got a negative 0.83333 repeating. Now, I'm going to write down, because this is the amount of money gained or lost, we're going to put a dollar sign. Okay, now looking at this one, I see a negative expected value. So the negative expected value means there is, uh, I am expected to lose 83 cents. So rounding it off to 2 decimal places. So I'm expected to lose 83 cents. Okay, so, okay. And if you're watching this live streaming right now and you didn't get it, if you didn't get this negative 0.83, let me know, and then maybe we can sort it out with maybe just the way the calculator it's typed in. Okay. Okay. So now what we're going to do is we're going to do letter B. Well, now that we've calculated the expected value, what is the meaning of this expected value that we calculated in part A, which is this one? So what's the meaning of that? The expected value of negative 0.83, so that means 83 cents, means that we are expected to lose, okay, because it's negative. Okay, I'm just going to put that here because it is negative. We're expected to lose 83 cents each time we play this game. Okay, so the expected value of negative 0.83 means that we are expected to lose, and I underline lose there because it's a negative. We're expected to lose 83 cents each time we play this game. Okay, so now we're on letter C. How much money could you expect to win or lose if you play it 100 times? Now, if we lose, if we are expected to lose 83 cents each time we play the game, then if we play it 100 times, then it's going to be negative 0.83, and that's in dollars, right? times 100. So this is how much we're expected to lose each game. Now, if we play 100 games, then it's going to be negative 0.83 times 100 is negative $83. Okay. Okay. So if you have any questions, unable to. Okay. Okay. So okay. I got a little message here that says unable to connect to chat. Please try again later. So I just put something out there, and if hopefully you can see it. I said hello everyone. Okay, so let's take a look at the next example. Example number 2. Let's read it together. A school is looking to have a fundraising activity at their school opening barbecue in September. They are going to have a spinner that is split in 10 equal sections. 2 of the sections say win, and 8 other sections say lose. A person can spin the spinner for $2. If the spinner lands on win section, the person wins $15. Calculate the expected value or expected amount for a person spinning the spinner. Now, sometimes it's kind of nice to see some kind of a visual here. So this is my spinner. I'm going to have 10 equal sections. So 10 equal, yeah, I'll pretend they're equal. Okay. They're not quite equal, but pretend they're all equal. So we got 10 different sections in here. Like I said, you don't have to draw this. I thought I'd just draw it out for you. So there's 2 wins. It says win, win. I'll just put win there, and then I'll put another win here. And then the other parts are lose. Okay, so here's a spinner. And so when you have something like this, what is the chance that we're going to win? So if we have a chance of winning, so the probability that we're going to win in this case is there's 2 wins. So 2 wins out of all possible outcomes. All possible outcomes, there's 10 of them. So this one here, 2 wins. And then the 10 would be 10 possible outcomes. Okay, so that's the probability. Now I think we're ready to do this part in here. So you go here, expected value, EV, and the formula at the front of this page would be probability of winning times how much we're going to win, amount win, minus the wording that they use, cost to play. There we go, cost to play. Okay, so oops, I'm going to go this way. Can't see that. So EV, I'm just going to follow this formula here. So P win means what is the probability I'm going to win. So if I'm spinning this, there's a 2 out of the 10 chances that I'm going to win. So 2 over 10 times. Now, if I landed on the win, how much am I going to win? If the spinner lands on the win, the person wins $15. So if I'm going to win $15, I'm just going to put 15 there. Minus the cost to play. Now, if I want to participate in this game, I have to pay $2. So I got to put 2. That's the cost to play. Okay, now we're going to take a look at our calculator. Okay, so if you are watching this now, go ahead and do this with me and then see if we get the same answer. So 2 okay, so I got 1. So that means $1. Okay, so I hope you got a $1 on your answer on your calculator. If not, please let me know and then we can help you out. Okay, so $1. So that means every time I win, every time I play the game, I am expected to win $1. So this is the do you think do you think this game is going to help the school raise money? The answer in that case is this is a person. The person who's playing the game is going to get $1. It's not the school that's going to get $1. So in this particular situation, the school, okay, maybe I'll write it off differently. So the player, I'll start with this. The player is expected to win $1. $1. So that means the school is expected to lose $1. Okay, so that means this game is not going to help the school to raise money. Okay, so in this particular case, the expected value is $1. So that $1 is going to the player who's playing the game. So not necessarily to the school. So the school is expected to lose. Okay. Now let's take a look at all of these notes will be on our blog after at the end of the lesson. So if you feel like you didn't have much time to write things down, it will be up and posted onto our blog. Okay, let's take a look at example number 3. Example number 3 says you just bought a raffle ticket for $10. You just bought a raffle ticket for $10. Any individual ticket has a 0.1 chance, 0.1% chance of winning a trip worth $8,000. So a ticket also has a 5% chance of winning a $35 grocery store gift card. Calculate the expected value of one ticket in this raffle. So take a look. In this particular case, when we buy a ticket, we could either win of a trip that's worth $8,000, or we could get a gift card. So we could either win the 8,000 trip or $35 gift card. So let's see here. Either one of those are considered a win, right? Because if you get the uh, if you get the ticket for a trip, hey, that's a win. If you get a gift card, that's also a win. So we have to consider both of them. So how do we do that? I'll write this down over here so that when we get over here, when we do all our calculations, it's nice and organized and we already figured it out. So um, probability of, I'll just say win $8,000 trip. Okay. Or we can say just trip. That's way too long. Winning a trip. So what is the chance that I'm going to win a trip? Now, the chance of winning the trip is 0.1%. Okay, stop right there for a second. Now, this is 0.1%. When we talk about percent, percent means per 100. So what we're going to do is to figure this out using a decimal. So 0.1%, 0.1 divided by, the word percent means per 100, so divide by 100. So 0.001. And it's this one that we're going to use, not the percent. Okay? And if we win this trip, we're going to get the value of the winning is 8,000. Now let's take a look at the other one. What is the probability that we're going to win the gift card? Okay, so the probability that we're going to win the gift card is 5%, 5% chance. So 5%, and again, the word percent means per 100. So 5, so do that on your calculator. 5 divided by 100, or 0.05. Okay. If you are already used to just moving the decimal to the left, you could do that too. Okay, now that these are all figured out and set up, we can do the expected value calculation over here. So let's do that. Expected value is equals to, now I'm going to write down the formula that we have on our the front page here, or page 12. Probability of winning times how much we're going to win minus cost to play. Now I have two different ways of winning. I can win the trip, or I can win the gift card. So in this particular case, we're going to write both of them down. So starting off with the trip, probability of winning the trip is, using this decimal, 0.001 times, how much am I going to win if I do that? It's the $8,000 value trip. Okay, so that's for the trip. Now, here's the other thing. Or I can win a gift card. So plus chance of winning a gift card would be 0.05. times, and if I win the gift card, it's worth $35. So times 35. I'll just put 35 instead of dollars there. And then now, that's all of my chances of winning. I can go now to cost to play. The cost to play is $10. So minus $10 because I had to pay $10 for this raffle ticket. Okay, now that we have this, we can just take our calculator and calculate this part. Okay. And we're going to see a kind of answer we get. Oh, okay. Now I got a negative value. I got negative 25, 0.25. Okay. So in this particular case, because the value is a negative, so we are expecting a loss. We're expecting a loss of 25 cents. So what is the expected value if you buy 7 tickets? So expected value if we buy 7 tickets would be negative 0.25 times 7 tickets. So it's going to be negative 1.75, $1.75. Okay. Okay, give you a moment to copy that down. If you have any questions, let me know. Okay. So let's go ahead and do example number 4. Yes. Example number 4. I actually have 2 more examples, and this is a not so bad lesson here. I'm just going to write down expected value equals to probability of winning times amount of money. 1 minus cost to play. Okay, so it says here, expected value analysis can also apply to any situation where there's a potential monetary gain or loss. So it's very, very applicable in business. So business is a common field where this kind of analysis is regularly performed. Example 4. It costs $1,000 for Sherry's construction company to bid on a construction project. Now, I mean, we don't really talk about this, but let's say um, they want to put up a building somewhere in downtown, and they're gonna say, and now there's different construction company that will make a drawing of it, make a bid to the construction of project. So this is happening all the time. Okay, so it costs $1,000 for Shares Construction Company to bid on a construction project. Due to the time involved in preparing the bid, If Sherry submits a bid on a project, there's 1 in 4 chances that she will be awarded the contract. Now, if she's awarded the contract, that is a win for her. If she is awarded a contract, she will be paid 3,000 for the work. Okay, so let's take a look at calculate the expected value of the situation. So expected value is probability of winning times how many is she gonna get if she win minus cost to play. Now, cost to play means the cost. How much would it cost her to be part of this bidding? Okay, so for her, let's see what is her chance to win. So if Sherry submits a bid on a project, there's 1 in 4 chance. There's our key there. 1 in 4 chance that she will win. Okay, so her probability of winning is 1 in 4. How do we write this in a probability? So 1 in 4 chance means 1 out of the 4 chance, 1 divided by 4. Okay, times amount of money that she's gonna win. So if she wins a contract, she will be paid 3,000 for the work. So times 3,000 minus cost to play. Now it's gonna cost her money to prepare all the stuff that she has to show. So that's a cost to play. So $1,000. Okay, so probability of winning is 1 out of the 4 chances, and if she wins, she's gonna get a $3,000 for the work, and then minus $1,000 that she had um, to start off with to get the bidding going, to participate in the bidding. So 1 divided by 4 times 3,000 minus 1,000. Oh no. Now it looks like she's gonna have an expected loss. So minus 250. So and that's an expected loss for her. And the reason why it's called a loss, because it's a negative value. So it says here, justify whether she should continue to bid on the contract of this type based on the expected value. She should not bid on this type of contract because her expected value is negative, which means she is expected to lose. Okay, so in this particular case, uh, if she's looking at this type of contracts, she shouldn't bid because she's expected to lose because it's a negative expected value. Okay. Okay. Give you like maybe a minute to just copy that down. And before we go on to example number 5, okay, so let's go jump into example number 5. If you didn't have enough time to copy this down, don't worry, I will post this online. So, last example, Aiko is a traveling salesperson. She drives all around the city every week selling high-end theater equipment. Her car cost her $260 each week for gas, insurance, and lease payments. Each week there's an 8% chance of her making a sale, and her commission on the sale is worth $3,250. Okay, so in this case, each week there's an 8% chance of sale. Okay, so 8%. And then if she makes a sale, that's considered a win. So 8% chance winning. And then this is how much she's going to get. This is how much money that she's going to get for that. Should Aiko continue selling high-end home theater equipment in this way? Justify your answer, making reference to the expected value of this situation. So before we say yes or no, we have to justify, meaning we have to prove it using some kind of a calculation. So let's see here. 8% chance of winning. So probability that she's going to win is 8%. Now, before we put that into our calculation, we have to write that as a decimal. So 8% means 8 per 100. So 8 divided by 100 is going to be 0.08. Okay? Now if you want to use a calculator, you just go 8 divided by 100. You're going to get 0.08. Okay, so that's her chance of winning. Let's go calculate our expected value. Expected value is, what is the chance of winning times how much money we're going to win minus cost. Okay, now I know it says there cost to play. She's really not playing a game in here. This is basically her cost. How much is she going to put into this situation? And her cost, cost to play, when you think about it, her cost is her gas money, her insurance money, and her lease payment, which is $260 each week. So, probability of winning, we just figured that out, is 0.08 times how much is she gonna get if she wins. Now she's gonna get her commission. It says your commission on the sale is $3,250 minus her cost. Her cost to get something is $260. Okay. So let's go ahead and calculate this. And if you're watching right now or you're watching later, give it a try. Okay. I got a 0. Okay. probably thinking, oh, if you got a zero, what did I do wrong? What maybe I calculated it wrong? Am I supposed to get a zero? Yeah, that's probably what you're thinking. So, well, what does that mean? Zero. So, it means her expected value is $0, which means she will not gain, gain or lose money. Okay, so that means she's breaking even. So she's breaking even in this particular case. She is breaking even. Mm. So we have to answer the question, should she still continue selling? So the answer would be no. She should not continue because she is not gaining gain oh, gaining from this sale. Okay, so there you go. There we have it. Okay, so just to kind of summarize our lesson for today, um, we talked about expected value, and expected value means we are how much are we expecting to gain or to lose. Okay, and we looked at the formula, and the formula is what is the chance of winning times how much we're going to win minus whatever cost that we have to put in to be able to participate in this game. And then if it's a positive value, that means we're expected to win or gain money. And if it's a negative expected value, then that means we are expected to lose money. So there you have it. If we take a look at assignment number 3, there are some questions in here on page 15. Going on to page 16. Now you're looking at this one here. What have we done so far? Okay, so we've done lesson 1. We did that last week. We did lesson 2. We did that last week. And then we just finished the expected value. Done. Okay, so if you take a look at this one here, we are halfway done in this probability booklet. So keep at it, continue working, and if you have any questions, please let me know. Send me an email. If you want to do virtual meet, I could email. We can set up a meeting for a virtual meeting through Google Meet, and yeah, we'll go on from there. Okay, so for today, I'm gonna leave this with you. Some assignment questions, and if you have any questions, feel free. Always feel free to email me, and then I will respond to you as soon as possible. Okay, so there you go. Well, have a good day of learning. Have a good day of working on this one. And I'll talk to you soon again. Okay, have a good day. Bye for now.